So, is everybody out there ready for some mediocrity? You know, just a standard mediocre Q&A live stream as usual. Nothing fancy. Don't expect any crazy big productions. Just kind of kick your feet back, relax, open up your favorite adult beverage. If you're not old enough, stick with apple juice. You know, see, there we go. Don't got my normal sounds right now, but I can improvise, you know. So let's cue up the intro music, and we'll be back in a second. Yo, what is up, everybody? So that did not work out as well. People are watching on Instagram right now. For some reason, as usual, when I try new things, it never works out. So I had scheduled a stream on YouTube and on Facebook, and for whatever reason, when I hit live, it didn't work. So I had to restart another stream. Go figure. It's how things work. That's why I don't try to mess with my stream very much. When I try to do new things, it just seems to not work out the way that I want it to. But regardless, we're streaming on YouTube now. We're streaming on Instagram, Facebook. That went out the window. Who cares about that? So guess that's not really going to work. One of these days, I'll hire someone that can help me figure all this stuff out. So welcome to the HVACR Videos Q&A live stream. So I'm trying to toggle in between two cameras because I've got Instagram over here. I've got YouTube over here. Let's see what we can get to. So I don't know how this is going to work as far as the questions go on Instagram. You can try and post questions or comments or anything that you want me to address on Instagram. I would highly suggest if you're going to post anything on Instagram, you put it in caps lock, okay? As usual, to my normal viewers that are on YouTube right now, I apologize. The stream got messed up and I had to start another one. So here we are. So I got a couple things I want to cover, but first let's start over, okay? Because we have some new viewers as usual. We constantly have new people coming to the stream right now. So I am an HVACR service technician here in Southern California. I started making these videos as kind of a training aid for my employees. And then next thing you know, here we are like 5 years later, and it turned into this whole thing. I never really anticipated it turning into what it did. And in all fairness, I don't treat it in the way that most people that you would call an influencer would, right? I try not to obsess about YouTube. I try not to obsess about social media. I try to just do my thing, right? I like making videos about service calls and how I approach things. These are the ways that I do it. I learn from you. Maybe you could learn a few things from me. Maybe it's just like, hey, don't do it like him because he's an idiot. I'm sure there's a lot of that going on when people watch my videos. But I want to stress this the most is with any influencers, anybody you're watching on YouTube, do your research. Don't just trust some dude because he said this is how it works and he sounded really convincing on YouTube. Do your research. So if you watch one of my videos and you hear something, you see something that looks interesting, do some research and verify that I actually did it correct. Don't just trust what I did, okay? Because anybody can be convincing, right? If I make a video on YouTube, I can edit it. I can edit the mistakes out. I can show you just the good things, okay? Now, I don't do that. I try to leave the mistakes in my videos as much as possible so that way you guys know that I'm a real person, that I'm a human, right? But yeah, so I'm just a normal service technician, nothing special. I put my pants on the same way. I freaking, you know, have the same issues as all of you. I'm stressed to the max all the time, right? That's just life, okay? I'm not perfect. I'm a human, just like you, okay? So as usual, I got a bunch of questions I want to cover. Again, if anybody's in the Instagram stream or if anybody's in the YouTube stream, make sure you guys put your questions in caps lock. I apologize to the people that are just finding this right now because, you know, whatever, my stream failed. It sucks because what happens is, and I showed the people on Instagram before because I started talking to them first, I have like a whole list of things, right? Questions. And I emailed all these people and I sent YouTube comments out to all these people. And I invited them to the stream with a link and everything. And then go figure, this is how streaming works. When I started the stream, that stream didn't work and it started a new one. So that link that I sent all those emails and those comments to invite people to the stream because I would answer their questions, they're going to click on it and it's not going to take them anywhere. And that's just one of the frustrating things about streaming. But you know what I've learned is don't let it get to you. It is what it is, you know? That's the most important thing because I used to get so stressed out about the live streams and how things work. And I learned just to take a chill pill and not try to take it so seriously. It is what it is, okay? So real quick, I wanted to address a few things. Been getting a lot of questions and comments about the stuff behind me, right? I've got some new pieces up on the wall. And then for those that just don't understand, there's some new tools or maybe a tool that you've never seen before, okay? So I want to talk about those real quick, and then I'm going to get to your guys' questions and get to the things that I have on my list in front of me. So starting over here, we have a, on the top up there, that is a hermetic compressor analyzer. It's an Annie, okay? I personally did not use that Annie. One of my employees gave it to me. Let me grab it. Because everybody's always asking about this stuff. So for Instagram, this is an Annie. This is a early model hermetic compressor analyzer, okay? For YouTube, the people looking right there, I have it as a showpiece just on the back. Now, I personally did not use this. This was given to me by one of my employees. I had a different compressor analyzer. It's actually hidden back there, but it's a big giant one made by Thermal Engineering. But this right here would have been used to start or to attempt to start a compressor to verify whether the starting components were bad. Sometimes, now not with this one, but, well, actually, no, you can. On this one, you can reverse the phases too. So, but you could rock a compressor back and forth, try to get it to break free, okay? So this is an older tool. Again, I personally never used this one. I used some different ones. Now, we really don't have a use for hermetic compressor analyzers as much these days. I'm sure someone can justify a use for them. But with the advent of 3-in-1 temporary starting components, you know, you can buy them. Some manufacturers make them. They have a relay and overload. They're not the same as the normal starting components, okay? But you can use them to try to start a compressor and see if it works. And then if it does work, then you can go get the starting components, okay? So I'm going to set this down and grab another one real quick. Next, back there again, I'm just talking about the tools that everybody's always asking me about that are in the background. So to Instagram, this is a Simpson 260 meter. This was the bee's knees when it came to meters. This was before my time. For the YouTube feed right there, Simpson 260. This was actually my dad's meter, okay? I learned from my father. My father used this before I started working with him. I don't doubt that this meter still works, but it's just a cool thing I found in the shop, and I threw it up there. I like this. Again, I personally did not use this, okay? I've been really kind of becoming obsessed with older tools, and I'm starting to have fun with it, going on eBay and buying old HVAC tools. So this was one that I didn't have to buy. It was kind of cool. Just found it in the shop, kept it for myself. Let's get on to the next one. So real quick, this is a dial-a-charge, okay? Personally, I have not used a dial-a-charge, right? Because when I started in the trade, in the mid 90s, digital scales were pretty prevalent. Okay. This was a very, very accurate way. And some people still use dial-a-charges. Okay. It's a very accurate way to measure refrigerant. Basically measures by volume, and you can see exactly how much you're going to put in there. Now, this one right here was specifically for refrigerant 12, 22, and 502. So the gradient scale would not be accurate on this to use it with modern refrigerants, because the pressure temperature charts and different things would be different on it. But yeah, this was a dial-a-charge. Again, I'm just kind of talking about these things because a lot of people ask me questions about them. And in all honesty, that's why I put these tools up in the background. They're conversation pieces. So this is one of my favorite tools right here. This is a Robinair leak detector. This was given to me by Chris Eads with AC, what is it? ACT, shoot, what is the name of his company? I'll think of it in a minute. AC Easy T? I think it's AC Easy T. He's a manufacturer and a business owner. And he had given this to me when I was at the HVACR training symposium. And I think this is one of the coolest leak detectors that I have ever seen in my entire career. Okay. Now, it actually works by, I have not used this, but it actually works by taking this wand off and getting it closer. But it's just a cool design because it looks like a ray gun, right? It looks like you're in Lost in Space or something like that, right? I imagine that this is only for chlorinated refrigerants, more than likely. But yeah, it wouldn't work with modern day refrigerants, most of them. But this is one of the coolest leak detectors I've ever seen. It'd be really neat if I could get a manufacturer to make like a new leak detector like this, like all retro. Coolest thing ever. All right, let's see what else we got. I'm just talking about a few tools, and then I'm going to get on to Q&A questions. So. This might be the heaviest one for Instagram. This right here is an amp meter, okay? For Facebook, for YouTube, this right here. I've shown this before. I found this on eBay. This is a Weston voltmeter, and it's for measuring DC current. Again, for Instagram, look at this thing. This thing probably weighs 25 pounds, and it's a portable amp probe, right? It had a leather strap on the side right here, and you were supposed to carry it around. And then depending on what the current of the devices you're measuring, you would change the little poles right here for different currents. But this was for DC amps. My understanding, I just found this on eBay and I couldn't pass it up because I think I paid like 20 bucks for it. And this thing is pretty darn epic. All right, so cover those because I get those questions all the time, all right? Next, what we're going to do is, yeah, I covered that. I'm looking at the chat right now. Again, if you guys have questions or things you want me to cover, do me a favor, put them in caps lock. I'll try to get to them. I'm still kind of figuring out this whole, it looks like HVAC reefer guy, Mike Mayberry's in the Instagram chat, and he says that he has a Weston voltmeter at home as well. Really cool piece. Like, Mike, I know you're all into HVAC history. For those that don't understand what's going on, I'm streaming on Instagram at the same time. So I'm looking at Instagram right now. But these old HVAC tools, they're just fun. They're just fun. I'm not spending thousands and thousands of dollars. Like I said, that Weston voltmeter, I picked it up for like 20 something bucks. South Main Auto Repair LLC. Thank you so very much for that super chat, bud. It's really cool to see you in here. I recently found your YouTube channel from some of my viewers that recommended your YouTube channel, and I started watching it, and I really dig your troubleshooting techniques. It's really, really cool to see other like-minded people troubleshoot the same way. So I consider myself to troubleshoot very similar to your method, and don't take offense to this, but I call it dumb logic, okay? I know how to use the sophisticated, super smart stuff too, but sometimes easier is better. And if you just break things down to the simplest methods of how they operate and then just work your way through, I call it dumb logic. Again, it just seems to work and click. So most of the time, I don't have to get all crazy brainiac. I just break it down, slow down, step back, think about the sequence of operation, work your way through the process, and it's awesome. So again, thank you so very much for that super chat. So let's see, going through the chat right now, looking and seeing what's going on. It's time for me to get a vintage Coke machine, someone said. Yeah, I'd be interested in picking one up. Ironically, I had access to one many, many years ago, but I wasn't in the phase in my life where I was interested in that stuff. So it would have been cool to keep. Yeah, for sure. So, all right. I'm going to get to a couple things I have on my list of things to talk about. So one of the most common questions, okay, and again, let me phrase this, okay? The reason why I do these live streams is to consolidate the questions that I get from my YouTube videos, okay? I have a family, I have a life, I run an HVAC business. It's hard for me to keep up with all the comments, the emails, all the different stuff. So I go to the most commonly asked questions and I consolidate them and answer them in a live format. So that's the point of these live streams, okay? And for those that are watching on Instagram right now, this is a thing that I've done for like 5 years now. Typically every Monday evening, I go live on YouTube and I just answer questions for days, okay? So in my recent video where I was working on a roof and I had to change a compressor, and I think it was titled, "They Have Sand in Places They Shouldn't." One of the most common questions I get, I've been working out in the Coachella Valley a lot lately, and we have sandstorms out there, and the sand is just wreaking havoc on our equipment, and everybody is asking me the same question. Why in the heck am I not using solid state relays? Why not use solid state relays instead of totally open compressor contactors, okay? Number one, they're not readily available in my local supply houses, okay? I shop at a few refrigeration supply houses. They typically don't have solid state relays. My quick research has led me to believe that most solid state relays can't really handle compressors, okay? That's my quick research. Now, I'm open to all kinds of information. If any of you have information to share with me that can enlighten me more, okay? I've got a bunch of people that sent me emails saying that Emerson makes solid state relays. They do. Emerson makes something called the Sure Switch. Okay, the Sure Switch is a great device. I have a Sure Switch on my own home's residential air conditioning system, but the Sure Switch is only made for single phase voltage. It is not made for 3-phase voltage. Okay, so my understanding and my quick research, I haven't spent weeks or days researching this, but my quick research says for the price, there is nothing available that's within reason that is affordable. Now, I do know, and I have read a lot of your emails and comments that said that they make industrial style controls that are totally enclosed. Yes, I get that. But trust me, with the customers that I deal with, yes, I could go to them and I could say, you know what, I can install a $1,000 contactor on this compressor and you more than likely will never have to change it again. My customer would not go for that, okay? The way that corporate money works is kind of weird in the restaurants. They don't want to go for that. They just want you to put another contactor back in and call it a day, okay? Then I get a bunch of people saying, how come, and again, we're talking about blowing sand that's just infiltrating my contactors, wreaking havoc on my refrigeration and air conditioning equipment on the roof. Then I get people saying, well, why don't you put them in a totally enclosed box and seal them? Okay, but those contactors, they put off a lot of heat. They have to be able to breathe. You have to put them in a box. If you were going to put them in a totally enclosed box, it needs to have some sort of ventilation. They do make stuff like that. You can get like NEMA 4X industrial boxes that have cooling fans that have filters on them that filter the air before it goes into the box. Like, and again, it's just not affordable. It's just not practical for these customers. They just don't see the value in it. Okay. So I'm limited by my customers and what they want to do. And I realized that if money wasn't an issue, we could solve these problems of this sand infiltrating everything. But with them, money is an issue. And the weird thing, and this is just how corporations work in general, at least the ones that I work with, is I can spend tons and tons of money, right? Or give them tons and tons of invoices to repair equipment, right? And every invoice will say, this could have been prevented if you did a preventative maintenance. This could have been prevented if you did a preventative maintenance. It doesn't mean anything to them, okay? Preventative maintenances are not something that a lot of the restaurants, the big chain restaurants, they don't want to do them right now, because this is my understanding of it. Now, this is just my opinion, okay? This doesn't necessarily mean this is exactly their thought process. But the only thing I can think of, as far as budgets goes, corporations have different kinds of budgets, right? And when you have planned expenses, that's just a guaranteed expense you're going to spend. And then you have emergency expenses, right? Emergency expenses aren't planned, and you have a budget, and it's just like, okay, it is what it is. So a lot of these people don't want these planned expenses, right? I had one of my big restaurant chains that I do something like 30 of their restaurants, and they asked me for a quote for preventative maintenances, right? They asked across the country all their contractors to give them quotes to start doing preventative maintenance on all their equipment. And I want to say, I'm really bad with numbers, but I want to say that, and then I know this is a big number, but that I want to say it was like $2 to $3 million a year is what they would have to spend in planned money to start doing preventative maintenances, and they just couldn't stomach that. Yet, I know it's just totally ridiculous. They're spending that in repairs, but it's just not planned, right? So I'm just this guy trying to fix their equipment and keep it operating. I give them suggestions. If they don't take the suggestions, so be it, okay? I always tell everybody, you can give big picture quotes all day long, but they don't have to accept them, right? But if you give a big picture quote and you document everything, then when they don't approve that big picture quote and they just want to repair the symptom, well, so be it. That's fine. We fixed it. We got it operating, but there's going to be more problems because they didn't look at the big picture, but at least I have it documented. I have it written down. So therefore, it's not going to be my problem. Okay. So I try as hard as I can. So next question, people were asking about solid state relays. They were asking about enclosing the contactors in big giant metal boxes. Then I had people asking me, well, why don't you install contactors with overloads, right? So you have the electromechanical contactors that you use for, and if you couple an overload with a contactor, you've basically made a motor starter, right? So motor starters are a good method too, but it's expensive, okay? The next question that I had was, how come I don't install phase monitors on all my equipment? Again, if you're trying to use a phase monitor to solve a problem of a single contactor that's going to go bad, you would have to install a phase monitor on every contactor, right? Because you need to see the load side of every contactor. You could install a phase monitor at the incoming voltage to the unit, but that would only be monitoring the incoming voltage. If your problem is on the load side after a contactor, you would have to install a phase monitor on every contactor. And in a perfect world, yeah, that would work. That would be a great idea. You install like a ICM, I think 450 or something like that on every contactor. Sometimes these compressors have 4 stages, right? 4 compressors. So you'd have 4 different contactors and then you'd have a blower motor. That would seriously prevent problems. It would. You could set it for high and low voltage. You can set it for high current, all kinds of different stuff. That would be a great idea. But again, that is a huge expense. If I had to guess how much it would cost me to go and install phase monitors after every compressor contactor, it'd probably be in the range of $600 to $800 per phase monitor, including labor and drive time and parts and materials and all that stuff. And that's a big expense. Yes, in the grand scheme of things, that would be a very smart thing for the customer to do because, hey, if the contactor failed, boom, it wouldn't cost them $8,000 to go change a compressor, because sometimes that's what they can cost on big jobs. It could be up to $8,000 to go change a compressor because of all the stuff you have to do, including travel time and all the parts you need and all that different stuff. So it would be smart, but sometimes it's like beating your head against a wall trying to convince these customers to do all this different stuff. Okay. So I try as much as I can. I'm looking at the chat right now. How hot would a compressor have to run for POE oil to reach optimal viscosity? That's a question beyond my understanding, but I mean, I don't know the answer to that one. I know that there's a thing right there that once you go past a certain temperature that you start to break down the oil. And I know that Copeland Compressors basically says that they don't want the discharge line within like 6 inches of the discharge of the compressor. You don't want the discharge line getting hotter than 225 degrees because now that's not 225 oil temperature, because the inside of that compressor is much hotter than 225 degrees. But at the outlet, they have determined that anything over 225 degrees on the outlet of their compressors starts to lead to issues within the compressor. So, but what the internal temperature is, I don't know those numbers right now. So let's see what else we got going in here. Let's see. Jason Johnson says there are lots of good products out there. Customers don't want to spend it, though, so you do the best you can, and that's exactly it, okay? So I try the best that I can. I'm not perfect, nor will I ever be, and it's very important for us to understand that. We're never going to be perfect, but we can always try to be perfect, right? Will, thanks so much for being a channel supporter for so long. Ike, I saw your thing pop up earlier too. Thank you very much for being a channel supporter. For those that are watching on Instagram right now, I'm talking about the YouTube chat right now. Let's see what else we got going on in here. Same thing goes. I got a bunch of people asking me why not install VFDs to run every compressor. That would be a great idea too, because then you would have soft start. You'd lower your inrush current when the compressors turn on. You could slowly ramp them up. The VFDs would have all kinds of phase protection, voltage protection, current protection. That would be a great idea. But again, it's cost. You know, it's just cost. That's really what changes everything. So let's see. Reading through here. How long would a VFD have to, how long would oh, that's funny, Laska, you're funny. Attention, Chingus. Let's see what else we got going on in the chat. Okay. At the end of the videos, I do have to say, again, it is what it is. I realize that some of my videos are long, right? It's funny because this last video was an hour long, and my daughter she helps me with editing. She doesn't edit the whole video, but she helps me. And she goes, Dad, she's like, your video's an hour long. Nobody's going to watch that. And I told her, I said, no, you'd actually be surprised. I said, now I can see the analytics. Yeah. Majority of the people do not watch the full hour-long video. But as I'm editing the video, you got to remember, my head is different than everybody else's, okay? I don't get offended if people don't watch my video all the way through. That's fine, okay? I get it. An hour is a lot of time to spend watching a YouTube video, okay? But I do things the way that I want to do them, and it's okay. You know, if you guys don't want to watch it, that's fine. But I'm going to continue to make the videos the way that I make them. So if I film a video and I see a lot of content, I'm not going to chop it up to make it a 20-minute video and cut out all the good stuff. I'm going to leave what I think is important for certain people to see. And if you don't watch it, it's okay. Again, it's no big deal, right? It really isn't. So I do things differently. I don't do things the way that YouTube says to do them. I don't do things the way that my sponsors or advertisers say to do them. I'd be interested for you guys to talk to my advertisers and my sponsors and the people that I do work with. I bet you they would tell you that I'm a little bit difficult to work with. And I am. I realize that I am, because I do things my way. And that's just how it is. When they approached me to work with me, or when I approached them to work with them, that was part of the stuff is, look, I'm going to do this my way. And if you want to work with me, great. If not, it's okay, right? So I do things my way. The videos are long sometimes. It is what it is, okay? But I will say, if you guys watch till the closing words, majority of the time when I'm editing the video, I see things and I'm like, oh, I should have done that differently. Or, oh, I know that's going to raise a lot of questions. So I will often answer most of your guys' questions in the closing words of the videos, okay? So if you watch till the end, you might get your question answered a lot of times. Or I'll talk about how I made a mistake and how I should have done this differently. Or I'll just recap and say, these are the problems that I had, you know? So in my recent video too, where I had a burnout because of sand, I think it was a low voltage issue causing overheat and different stuff, right? I did an autopsy at the end of the video. The first question that I got a bunch of times was, why didn't I do an oil test? And I'm going to ask you this. What is the point of doing an oil test when it was clearly a grounded compressor that burnt the refrigerant and the oil? Now, the refrigerant didn't smell that burnt, but it was burnt. When I poured that oil out, it was black. That was acidic oil, okay? So what's the point of doing an acid test? I know it was acidic. I know it's acidic, okay? In my opinion, an acid test, is there before preventatively with an operating system. If you have suspicions, if you have a sight glass that has an acid indicator and you start to see it change in a different color, yeah, do an acid test. Find that you have low levels of acid. Maybe you can remedy that by doing oil changes. You can prevent the compressor from catastrophically failing. That would be the point for an acid test. But when you have a completely grounded compressor and the oil's black, I don't see the point in doing an acid test. There's acid, right? Now, at the end of the compressor change out, after you've got the new system up and running and it's been running for about a week or two, yeah, it's probably a good idea to go over there and do pressure drop test across the dryers and maybe do an acid test. I think that's a good idea. That's just the way that I've done things. Is that completely the right way? Not necessarily. It's not necessarily the right way for everybody. That's just how I do things. So I don't see the point in doing an acid test when I completely have a grounded compressor and there's clearly acid in it. I don't do an acid test, okay, because I know it's there. The acid test, in my opinion, would be for after you have the new compressor running, after it's been running for a little bit, then go back to an acid test, see if you were able to clean everything up. Now, in my situation, it really depends on the customer. Some customers allow me to go do follow-up visits all day long, and I'll do acid tests, I'll check filter dryers, all that good stuff. Some customers don't. Some customers just want it repaired, so I'll go big with the repair, and then they just want us to monitor it. So in this case, this particular customer doesn't want me to go back for a follow-up. They don't want me to go back to do acid tests or check filter dryers. So the next time we're there doing preventative maintenance, we'll check up on it and see how it goes, okay? All right, let's see what else we got going on in the chat right now. All right, looks like we got lots of great friends in here. Hello to everybody that's in there. Hello to everybody that's on Instagram. What are the best practices, Eli asks, for as far as PMing goes for Hoshizaki ice machines? Okay, I'm going to tell you the number one problem with Hoshizaki ice machines is undersized water lines, okay? That leads to the biggest amount of freeze-ups is undersized water lines, okay? It's safe to say that if you have a Hoshizaki ice machine that is more than a 900-pound machine, that you need a half-inch inside diameter water line going to that machine. Okay, that's it may be that you don't necessarily need it for a 900-pounder, but that's fine. Okay, now remember, that's inside diameter, so that's a 5/8 refrigeration line. Okay, you need a half-inch water line. But not only do you need a half-inch water line, you need to make sure that it's a true half-inch, okay? You don't want a half-inch water line that goes to an angle stop that has a 3/8 going into the wall, because that's not a half-inch water line anymore, right? Hoshizaki's theory is that they need a certain amount of water going to that machine, and it needs to be high-pressure water. I mean, within reason, it needs to be at a certain pressure. If you're working on almost all the other ice machine manufacturers that you see in restaurants, Isomatic, Manitowoc, Scotsman, typically, they don't require high-pressure water going into their machines. They don't require the big, giant water lines. But Hoshizaki's, typically, for the 900 pounds and up, they have a 5-gallon water sump on those machines, okay? When you deal with the Manitowoc, Scotsman, Isomatic, those guys have like a half-a-gallon water sump, right? And they fill multiple times. But Hoshizaki's, they fill up in the beginning with the standard KM machines, right? You get into like some of their weird other machines, they do weird stuff. But so the first thing when you're doing PMs on ice machines is look at the water lines. What size are they? Are they the right kind of water lines, right? Then cleaning, routine cleaning. Now, I'm going to give a blanket statement that when you're working on a Hoshizaki ice machine, that machine needs to be cleaned minimum every 3 months, okay? Now, I realize most restaurants don't do that. They don't want to clean their machines every 3 months, but if they all cleaned their machines every 3 months, had a deep clean done on their machines where they empty out all the ice, you run ice machine cleaner through it, you break the machine down, you scrub all the parts, you put it back together, you put proper water filters on there, and you change the water filters periodically, and you have the right size water lines, those machines are going to last a long time, okay? So there's a lot of other stuff that you can check on a Hoshizaki ice machine, but the number one thing I'm going to tell you is make sure the water lines are the right size, okay? Let's see what else we got going on here. Warranty compressor comes with a free inspection report. Ask your supply house. Replacement comp, have to pay, but still get a report. Oh, yeah. If it is under warranty, yes, you can take it and you can request that it gets shipped back to Copeland or whoever manufactures it, and they can inspect the compressor and tell you what the cause of failure was, so that way you can address it. Yes, that is something. I will say that Emerson Copeland, strongly suggests that if you're working on semi-hermetic compressors, Rasmus Jensen, thank you very much for that super chat, bud. That's really awesome. Thank you so very much. Copeland recommends that if you're working on a semi-hermetic compressor, they strongly recommend that you disassemble. You open that compressor up and you take it apart and you figure out what's going on with it. They don't require on semi-hermetic compressors for the compressor to be completely assembled. They just require that it be sealed. So if you pull the parts out of it, if you pull the valve plates off and different things like that, and you don't know, you just shove them in the compressor, put them in the crankcase. That's all they need. They just want the parts in there. It doesn't have to be assembled. Okay. So Copeland encourages that on semi-hermetics. Now, on scroll compressors, they don't want you cutting those open because they need to see what's going on. But if it's not under warranty, I highly suggest all of you cut open your compressors, investigate them, dig into them. I love digging into my compressors. I still don't know everything. I lean on friends. When I was autopsying that compressor that I did on Sunday with the sand video, I called my buddy Trevor Matthews, who used to work for Emerson Copeland, and I said, look, I know this was an electrical failure. I know that there's no damage to the scroll plates. Like, I know it had nothing to do with that, but I was asking him, how do I differentiate between a single phase situation and a low voltage situation, right? And that's what we're trying to determine. And based off of what we were seeing in my video, he even wasn't sure. And he's like, you need to forward that on to, Copeland people and let them look at it, right? And so that's actually, I'm going to get Trevor a bunch of pictures and have him forward it on to his friends over there and see if they can give me any ideas. What is it going to do for me? Not much, because I know it was because of that contactor that failed, but I just want to know. I like to know. I like to start to recognize trends. So when I pull them apart and I see like, oh, it's grounded, or, oh, it's got these little rings in it, this galling going on in the scroll plates. Oh, that's flood back, Like, I like to learn that way. Again, dumb logic. That's what I use. I use dumb logic. I look at things, I see it, I remember, I learn from it. So let's see what else we got in here. What do I think of the R448 retrofit from 404? Does it make me hate tree huggers? Tyler, HVACR Tech. I use R448A all day long. First thing I'm going to tell you with 448A, okay? I know that manufacturers, especially Honeywell Refrigerants, I have friends that work there, great company, but oftentimes they will downplay things and say that, like for instance, with 448A, Honeywell says you don't necessarily have to change the expansion valve. If you're retrofitting from 404A to 448A, they tell you you don't have to change the expansion valve. Oftentimes, if the expansion valve is sized properly, you can reuse the same valve. Now, okay, that is true. But when you're doing a retrofit, just change the expansion valve. Change it over to a 448A valve, okay? Change the guts. If you're changing on a 404A system, look at the nozzle size, because the nozzle size oftentimes will be different. That's the little piston-looking thing that comes after the expansion valve. Oftentimes, the nozzle will be different. Yes, you can make it work. You'd have to play with it and adjust it and do all kinds of things, but why not just change the valve when you're in there? Now, I realize if you're doing a supermarket and you've got 150 valves, it's not very practical to go change every single valve, so you're going to do your best. Realistically, do your research. Find out if the valve is sized appropriately, okay? Let me say this right now. If you have 404A and you have R22, okay? You have two expansion valves. This right here happens to be a R12 expansion valve, okay? So what I'm asking the chat right now, I'm asking on Instagram and I'm asking on YouTube. What makes this valve an R12 valve? What about the valve makes it an R12 valve? Is it a single component on the valve, or is it multiple components on the valve? And which ones are they? I'm asking in the chat. Put your answers in there. There's no wrong answers. We all learn from this, okay? Now, I'm going to say that sometimes you can use this valve on other systems. There's times that you can on other refrigerants. There's certain times. It's a very, very small window. But what about this valve makes it? Laska says the power head. Does anybody else out there have any idea what makes this valve specific for the refrigerant? Is it just the power head, or is it something else that goes with the power head? I'm asking everybody, okay? Anybody that's in there. Gaskets is one answer. I'm looking through the Instagram chat. Nothing yet. Go ahead and give me the power head. Okay, I see another person saying the power head. It's the gas in the bulb or the power head. Okay, the spring. Okay, so there's a lot of answers in here, and they're not necessarily wrong answers, but it's not just the power head, okay? The orifice in the valve can be specific for the type of refrigerant that's being used. Now, sometimes you can change the power head and you can solve your problems because the orifice, the valve internals might be sized appropriately for that refrigerant. There might be enough play in there to make it work. But it's not just the power head that makes the refrigerant type for this valve, okay? The power head is one of two things, and it's the nozzle size, okay? You size an expansion valve based off of the capacity and the liquid line temperature or the liquid temperature coming into it. If you guys want an example, I don't have one here right now, but you know, let's just say that you have a 404A valve on your van, you know, quarter ton 404A valve, right? And you're working on R22. Some would think that, oh, all you got to do is change the power head. Not necessarily true. Sometimes that might work, but other times the orifice in the valve might not be big enough or small enough for that refrigerant. So it's not necessarily just the power head. So the point I'm trying to make is when you read manufacturer's instructions, you have to understand something. These refrigerant manufacturers, they want to sell their refrigerant, okay? And they want you to have to do the least amount of work possible to install that refrigerant because it makes them successful and you buy more of their refrigerant. Case in point, when it comes to converting refrigerants, drop-in refrigerants. Oh my gosh, that's such a voodoo term. Drop-in refrigerant. Okay, drop-in refrigerant does not mean mix the gas. Drop-in means that there's minimal work that has to be done in converting just the refrigerant over to the replacement refrigerant. The drop-ins, the first ones we were dealing with were R12 drop-ins, okay? One of the most common R12 drop-ins in the early 90s, mid-90s was 409A or MP39. That was another one too that 401A I think was MP39, but 409A was another one. Now, the term drop-in came out, and lately a lot of people seem to think that drop-in refrigerant means that you just dump it on top of the other refrigerant in there. That is absolutely not correct. You don't make your own refrigerants, okay? But when it comes to the refrigerants, I'm losing my train of thought of where I was going there. So yeah, there we go. That's how that works. I go off on a tangent and then I forget what I'm talking about. All right. So now that I totally went off on a tangent and I was going to say something, I'm totally forgetting here what it was that I was going to say. And I know I was going to make a good point, but I was talking about the refrigerants. I was talking about drop-in refrigerants. Oh, I was talking about refrigerant manufacturers, okay? So refrigerant manufacturers out there of the drop-in refrigerants, they want you to do the least amount of work possible because they want you to buy theirs. But I'm going to challenge every one of you to go read the installation instructions for insert name of any refrigerant, okay? And read the installation instructions, and preferably a drop-in refrigerant, right? Something that replaces R22, something that replaces 404A, something that replaces R12. And if you read the installation instructions from the manufacturer, down at the bottom of the installation instructions, there will be caveats. There will be blanket terms that say, if your system has high pressure drops, if your system has long line set runs, this refrigerant works best with polyester oil. And I'm talking about the R22 replacements. All these different ones that everybody makes, MP39 or MO99, 407C, all these different ones, 401B, insert whatever flavor of R22 replacement out there. Some manufacturers say it works okay, you don't have to do an oil change. But even on that same document that says you don't have to do an oil change, if you read down to the bottom and it says, in situations with high pressure drops, in situations with long line set runs, works best with polyester oil. So their own installation instructions contradict themselves because in the beginning, it says it works fine, no oil change necessary. But then down at the bottom, it says, oh yeah, if you got to do that, you probably need to change the oil. So it's safe to say the easiest way is if you're working on an R22 replacement, a drop-in refrigerant, you're not going to mix it. You're removing all the refrigerant. You're changing the dryer. You're changing the seals. Your best bet is to change the oil. Fight me on that one, okay? Manufacturers fight me on that one. I know that everybody out there is going to say, I've been doing it for 20 years and I've done it for years and you don't know what you're talking about and it works fine. And that might work, but there's those few times that it doesn't work fine. And I'm not okay with those few times. So I'm not mixing refrigerants. I'm not dropping in this refrigerant and not changing the oil. Oh, the one that drives me nuts. There's a certain influencer out there, not going to name names, but he has a video and it's just like, it's more ignorance. I don't think he meant to be wrong, but it's just because there's so much misinformation out there. And I blame the supply houses for a lot of the misinformation. But what he did was, in the video, he literally said how to convert a system to 407C. And he has an existing operating mineral oil system. He didn't do anything to it. He's using the same compressor. And what he did was he took 20% of the oil charge, whatever that number was. Let's just say it was 30 ounces. So he took 20% of 30 ounces and he put polyester oil on top of the existing oil. So he added 20% oil to that system and then said, this is how you do it. That is not how you do it. If you talk to any compressor manufacturer out there, they do not recommend adding 20% more oil to the compressor. No, 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 no. A lot of people misread that information, and what they say is that when you're changing oil, oftentimes there's going to be a small percentage of mineral oil left in the system after you've done multiple oil changes. Because if you do an oil change on a compressor, you drain out all the oil and then you put polyester oil in it, there's inevitably still going to be some mineral oil in the system. And so you let it run for a few days and you come back and you analyze the oil, or you just change it again, because each time you change it, you're going to have less and less percentage. And oftentimes they'll have an acceptable rate of percentage of mixed oil. And a lot of people are misinterpreting that, thinking that you can just add extra oil to the system. No, that's not how that works. There's a lot of misinformation out there. Again, like I said, don't just trust some dude on YouTube that tells you how to do things. Do your research. I caution you to go to the supply house and let them tell you how to do it, because you will get a lot of misinformation from the supply house. You need to do your research. You need to do it. You need to call the manufacturer. Call Copeland. Ask them, hey, I'm changing over to this refrigerant. Do you have any guidelines? Call Honeywell Refrigerants, whatever, insert whatever name of refrigerants, ask them, what are your methods? And then don't be afraid to ask questions, right? If you call Copeland and Copeland says you need to do this, and then you call, insert name of refrigerants, DuPont or whoever, and they say, no, you don't have to do that, then say, wait a minute, Copeland says I do, and you say I don't. So who's right here? Ask the questions, challenge them, get the answers. Don't just trust the supply house, okay? The supply houses, sometimes they can give you good information, but I've been given bad information by supply houses. I've had supply houses tell me, oh yeah, you just mix that. Who told you can mix that? Well, the last service tech, he says he does it all the time and it works fine. The last service tech is not the person I want to listen to. I want to listen to the manufacturer, and I want to know how to do it right. So do your research, okay? Be cautious about that. Now that I went off on a crazy tangent, let me get to the chat and see what I'm missing in here. Let's see. Mike B says he has a whole jug of R12 and R22 on his van. We still use that in Virginia. I have about a half a jug of R12. I have no use for it anymore. I have probably 3/4 of a jug of 502. I got 408, 409, Hot Shot. I think I might even have some MP39 still in the shop. Just like, I don't know why I kept it. I probably just need to get rid of it. But yeah, I still have a few of those. But I still use R22 all day long. So that's still very common. Can a grounded compressor turn on and run HVACR videos? Well, it depends on if it's a direct short to ground or if it's an intermittent insulation failure. Like recently, I've got a system, an air conditioner out there running right now that trips it blows a fuse about every 2 months, okay? And I've tested it, and the compressors have intermittent shorts to ground. I got my insulation tester on them and I tested it, and yes, they do not have a good insulation test reading. And I've been the only person to work on them. They're not full of moisture. There's no other variables that are causing that bad insulation reading. But yet the compressors are still running. They just blow the fuses about every 3 months. We're in the process of replacing those compressors. So yeah, I guess there's an instance where a compressor could be grounded and still run if it's just an intermittent short. But if it's a direct short to ground, nah, that thing's not going to run, and it's dangerous if it's running, right? So how can you know the volume of refrigerant you need to fill a given system? It depends on how the system was designed. If you're working on a residential split system, the manufacturers will typically tell you that if you're looking at, like, let's just say you're working on the home air conditioner at my house. I have a 4-ton Arco Air system out there. And on the nameplate, it has refrigerant charge. And it says, let's just say 4 pounds of refrigerant, okay? That 4 pounds of refrigerant is only for a certain length of line set, usually a very short amount. And anything past that, you have to add extra refrigerant depending on the length of the liquid line and the line set in general. So the manufacturers typically have charts that'll tell you how much extra refrigerant to add. This is especially important when you're working on heat pump systems, because heat pump systems are very critical to get charged correctly, especially when they're operating in the heating mode. So you weigh in the charge on most residential split systems and most heat pumps, depending on the length of the line sets. Now, you also will typically dial in the charge. Once you get the weight close to where you think it should be, you'll turn it on and you'll check your system vitals. Your airflow is number one. You have to have the right airflow for your system before you start adding refrigerant. If your airflow is too low or too high and you add refrigerant, there might be repercussions because of that. Now, I'm not going to say I've never added refrigerant to a system that had low airflow. Yeah, I have. Okay. Sometimes you got to do what you got to do, but it's really going to be your system vitals after that. So once you weigh in the charge, then you kind of look at the vitals and figure that out. Austin Kuhn, thank you very much for that super chat, bud. That is really awesome. Any tips on getting your journeyman refrigeration? You've been in the trade since 17 and you turned 21 this year. Well, I appreciate the nice words, man. That's really cool. I mean, I would just say, just make sure that you study up for it. I don't know what the journeyman test consists of in New Mexico. But I mean, realistically, you've been in the trade for quite a while. So I would start studying up, reaching out to whoever runs the test and ask them for a study guide or something. And then you can look into that. Feel free to send me an email if any of you guys, if I missed your questions or you want to talk in more depth, hvacrvideos@gmail.com. Okay. I had a question in a recent video where I was talking about a high traffic door, or I call them dairy doors, and those are just the swinging revolving doors that go in and out. Someone asked if we would be using those on walk-in freezers. No, you're only going to use a high traffic door or a dairy door on a walk-in cooler. And even then, they just lead to issues because they have a lot of air leakage around them. They're typically, you'll see a high traffic door walking into a kitchen or something like that. It's the ones that's on hinges and they swing back and forth both ways, but they make those for walk-in coolers too. But yeah, you're not installing those on a walk-in freezer. No way. They don't have the sealing capabilities that most don't. Why don't my walk-in coolers use alarms? I get that question, I swear, every week, because a lot of my videos are iced up walk-in freezers and different things. So why is it that we don't use walk-in freezer alarms and different things like that? And it really just comes down to the customer not wanting to spend the money to install alarms. I have installed alarms in several restaurant chains out there, like when the door thermometers go bad and they had a digital one, like I'll install a new one that has an alarm, and it'll be an audible alarm that'll beep and scream at you, and I'll go back a couple weeks later and the alarm little thingies will be covered in duct tape, and the managers don't care. So oftentimes, again, this is an opinion of mine, the corporate restaurants, they typically don't want door curtains put on their walk-ins. They typically don't want door alarms put on their walk-ins because the door curtains, the cooks don't like them. They don't like walking and having them hit them in the face, so they end up ripping them off and just throwing them on the ground. Oh yeah, that's great. Yeah, just fire all the cooks and hire new ones, but that's not how that works, okay? The restaurant industry is really difficult right now. It's a struggle to get them to keep on top of everything and just even maintain their own equipment. So I already answered that question. Going through my list of things to talk about. What do I use to cut open compressors, and what do I use to cut open all my parts that I have? Okay, so right behind me, I actually have a lot of parts that I have cut open. I do a cutaway of an expansion valve, thermal expansion valve. This is a Sporlan valve right here. And I've done cutaways. You can see inside of them. You can see the operations and how they work. It takes a lot of patience and a lot of trial and error. When I cut open the parts, I actually have a jig that I set a big bandsaw into. It's called the Portaband Pro. And I set my big bandsaw in there, and then it has a tray, and I can feed the parts across safely without cutting my hands off, and I get them cut, and then I'll polish the valves up. So that's how I cut the valves open. I have several different components here. I have a liquid line solenoid valve. I have a head pressure control valve that I've cut open. And again, it's a lot of trial and error. So in order to get this head pressure control valve that I have right here cut open this way, I probably went through 3 of them. So it was quite expensive. I went through 3 valves to get this nice of a cutaway. Now, in my situation, I was able to lean on Sporlin and say, hey guys, would you mind sending me like 4 or 5 of these? Because I'm about to butcher them so I can get one good cutaway. And they said, sure. So they hooked me up. I cut them open. Or I just have old parts at the supply houses. There doesn't have to be a brand new valve. When you unsweat a head pressure control valve that's not working, take it home, open it up, cut it open, learn how to do it. They're not going to be this perfect at first as these two right here, okay? But it just takes time, and then you get to them, and then you can use them as training aids for people to see like how this valve works. As far as the compressors go, I use a grinder with like a 6-inch grinder disc, and you just go through. It's just time. Just learn. Again, every time you cut open a compressor, the first time you're going to butcher that thing. You're going to cut it in all the wrong places. You're going to cut all the internal components. But once you've cut open enough of them, you'll start to learn, and you'll be like, hey, I know where to cut this. You cut, you know, a 1/4 of an inch above the weld on the top of a Copeland scroll, so that way you can see the top side of the muffler plate. Then you cut a 1/4 inch below the weld on the top of a Copeland scroll, and then you pull the dome off, and then you can see the floating seal right there and all that, and then you cut down the seams and then look down the compressor. It's just trial and error, just getting in there and learning. Drain the oil first, and you'll learn, and it's messy. You'd see the back of my yard is just nasty. I have like a little thing on the side of my house, and it's just all dirty over there because I cut compressors open all the time. So DeWalt has a portable pressure washer that can draw water from a bucket. Yeah, I have seen that before. I've never personally used it. That's from Instagram. And yeah, I have seen that. There's a couple manufacturers that make different ones. It's like a little pressure washer, and it sucks out of a bucket, and you can wash things. I guess that could be beneficial for washing very small condenser coils on the roof where you can't necessarily get water. In weird situations, I've had to go buy transfer pumps from Milwaukee and then take buckets of water on the roof because they had very little water pressure. So when I would turn on the hose, like it would initially pour out, and then it would just be like blur, you know, just like nothing. So then I put a transfer pump on there to boost the pressure just a little bit, which is not the intended purpose of a transfer pump, but it worked for my situation. So, all right. Do I like the Hvacr Micron gauge or the field piece? What is it? The MG44 Micron gauge? I think that's what theirs is called. Which one do I like better? Well, I mean, it really depends on the situation that I'm working in. The Hvacr Professional is probably the most sophisticated micron gauge out there, but it's quite expensive, okay? And it's not necessarily needed for everybody out there. Hvacr also makes some like Hvacr Mini, and they make the non-professional version. There's differences in them. The professional version gives you communication within the app, and then some of the lower versions just have a really good sensor, but they don't necessarily have communication with the app or something like that. The field piece micron gauge is a great micron gauge, the new one, the MG44. Okay, they used to have a round one, and that one was problematic, but the new one is a really good gauge. So it really depends on the job that I'm doing and how I'm going to measure it. I use them both pretty equally, but I do have to say that the Hvacr professional micron gauge is probably the most sophisticated, most accurate, affordable micron gauge that I have. Okay, so the Hvacr Pro, and then the field piece is like right below that, and I use both pretty equally. They're both in my vacuum kit, and I trust them both. They both have great things about them. You want to know something interesting that I heard, and I don't know this to be completely accurate. Do your research, but some micron gauge manufacturers, if you've ever used the Hvacr micron gauge, you'll notice that it's like, dude, every system I work on, you know, when you start to do your decay, it's like boom, it goes high really quick, but then you'll use another micron gauge and it doesn't climb as fast. Yeah, that's in the programming, by the way. Okay, so understanding that there's going to be a leak rate for every system out there. Nothing is 100% leak free, and it's all about time and doing your decay test and what you settle on as being an acceptable leak rate. Okay, so keep in mind that just because you notice that insert name of micron gauge, well, this one doesn't move as fast when I turn off my stuff, so the other one sucks. No, the other one might actually just be too accurate. So remember that and do your research. Again, don't just trust some dude on YouTube. Okay. In a recent video with the sand video, again, a lot of these questions are about my sand video. I was pulling the blower assembly out, and I mentioned that when I started up, it was going to blow sand everywhere. So someone had asked me, when I pulled the blower assembly out to tighten the belt, why didn't I just start it up so that we blew the dirt out of the unit? Well, that's a double blower. The one that everybody saw me pull out to adjust the belt, there's another blower that same size back behind it. It's a double blower. So the only way to get that completely out of the system would be to have 3 guys. Those things are heavy, by the way. 3 guys over there. You have to take the motor off and then lift the whole skid out, clean it, put it back in. When you're working in sandy places like I was, just it's inevitable. Every time I turn the air conditioner off and turn it on, all of their tables downstairs get covered in sand, and the restaurant just knows it. It's just something they have to work with. Rock and Soul says, does the field piece hook up to Measure Quick? No. Jim Bergman has said that the only Micron gauge that will work with Measure Quick is the BlueVac Micron gauge. That's it. Jim has an affiliation with BlueVac, and he within Measure Quick, the only one, he has said this, maybe he'll change his mind, but he has said the only one that works with Measure Quick is the BlueVac Micron gauge. You can use all the other field piece tools with Measure Quick, just not the BlueVac, or just not their Micron gauge. All right. What of the motor is separate from the compressor with the belt and the pulleys? I don't quite understand your question, bud. What of the motor is separate from the what if the motor is separate from the compressor with belt and pulleys? So like a belt drive or an open drive compressor. So yeah, those do exist. They are still out there. And in that situation, I don't know what you're asking me though, but that is a common thing in heavy industrial and some older supermarket systems. You would see open drives where you'd have an actual hermetically sealed compressor, and then you'd have a shaft sticking out with a shaft seal, and then you'd have a drive on there. But I don't understand what your question is. So feel free to try to post it in the chat. If I miss your question, feel free to send me an email, okay? hvacrvideos@gmail.com. Jason Johnson says, decay test. Valve off vacuum pump. Watch how far microns go up. Leak, it'll shoot up fast, slowly above a certain level moisture. That is absolutely true. And well, yeah, I can't seem to find my evacuation book. I was probably in another room because I was reading it. But Jim Bergman and Brian Orr revised a book that they sell at TrueTech Tools. If you just go to truetech.tools.com and search evacuation, right? Just to search evacuation, the book will come up on their website under some of the tools. And read that book. Jim Bergman and Brian Orr have done a great job in illustrating and breaking down a lot of different things about evacuations, and they make it a little bit easier to understand about the whole process and how to analyze. One thing that I love about the BlueVac app or the Measure Quick app when you're using the evacuation feature is the graphing that they have on there. And the graphing tells you so much, because if you watch an evacuation and you watch it slowly come down and it keeps doing this, like doing this, that typically means that your Schrader's not being depressed or there's oil on the seat of the Schrader. So you fix that, and then you notice your evacuation drops way down, and then it just stays steady as it's going, right? Just stays steady. And then when you go to valve it off to do a decay test, it just goes straight up and then it just keeps rising. That typically means a leak. But if you start to notice that it goes gradually up at like an angle, that typically means that you've got moisture in the system. But also understand that there's always going to be an acceptable leak rate. It's never 100% leak free. There's always going to be a little bit. So keep that in mind. But yeah, I can't remember it's called The Review of Vacuum, I think is what it's called, or something, if I remember right. But it's a great book, great little reading thing. How do I work when it's over 100 degrees outside? So many people question that when I say it's like 111 or 115. How in the heck am I working on the roof? First off, I'm true when I'm saying this. When you're working in 115 degrees, you are slowly dying every minute you're up on the roof, okay? You are slowly dying. So it's about hydrating yourself. It's about not letting your body get overheated. The longer that you work outside, the warmer that your body's going to get, and eventually you're going to start to feel sick. You're going to start to feel the effects of heat exhaustion and different things like that. So if you're not used to it, don't ever put yourself in those situations, okay? I live in Southern California where we deal with 100+ temperatures all the time, and it's just part of my job description. So I make sure I take lots of breaks. Now, y'all will think I'm crazy, but we don't have humidity here, okay? It's just really dry and it's really hot. I wear a black undershirt, like a Under Armour, sweat wicking shirt. I wear that, and then I wear a Dickies long sleeve shirt, button-up shirt, every single day, even when it's 115, 120 degrees out in the sun. For me, that works well because it keeps the sun off my skin. And it also keeps me protected from the sun potentially causing skin cancer by burning my skin too. So long sleeve shirts work well for me. Now I realize that if I worked in a really, really humid environment, that wouldn't be as practical because it's not going to work so well. But in a dry climate, that works great for me. So Kenneth Landis, thanks so much for continuing to be a channel supporter. That is awesome, bud. Okay. Let's see what else we got going on in here. One thing that I will say, someone mentioned that the sweat in the eyes at 100 degrees hides the tears. The interesting thing, at 100 degrees, the sweat starts to run off your forehead and it pulls all the salt and all the chemicals that are on your skin, and it gets in your eyes, and then your eyes start burning, and it just hurts because there's all the salt and all the chemicals that are on your skin and the oils and different things, and they burn the heck out of your eyes. So careful rubbing your eyes when it's really hot outside. Why didn't I use flush? Why don't I use flush? Okay. I don't use flushes anymore. In the beginning part of my career, I used them all day long because the supply house said, hey, when you have a burnout, put this in, it solves the problem. First off, for the majority of my career, I didn't use the flushes right. It wasn't until I was taking a training class with one of the new Calgon guys when he was explaining how RX11 flush works. They're the manufacturer of RX11 flush. This was probably 10 years ago, something like that. And he was explaining that if you read the instructions, which I don't do a good job of reading instructions, I never have, okay? If you read the instructions, they tell you that when you put a flush into a system, it's a solvent, right? And that solvent, the idea is that it's going to evaporate, right? Because it's what is it? Anyways, before I try to butcher myself on that explanation, but it's a solvent and they want it to evaporate, and then they want it to mimic the characteristics of R11 because they used to use R11 refrigerant to flush a system out, okay? So you put RX11 in the system and then you chase it with nitrogen and you purge it out. And the theory is that it boils out and then it blows everything out. Well, if you actually follow the installation instructions of RX11, what you're supposed to do is you're supposed to create a restriction at the outlet. You're supposed to pinch the line down until it's a tiny little opening and then blast the system with nitrogen. And what it actually does is it takes that flush and it makes it back up against the walls of the pipe, and then it scrubs the walls of the pipe, and then it pushes it out that tiny orifice, creates a big pressure drop, and pushes it out. I never even did that for most of my career. So my question is, what was happening with that solvent if I wasn't completely, or what potentially could be left of that solvent? We're trusting the chemical manufacturer to say it's safe to put in the system, but does the compressor manufacturer say it's safe to use in the system? Do they say that you're good to go? I personally have made a choice that I don't really use additives anymore unless it's recommended by the compressor manufacturer to do so every single time. I get by without using flushes just fine. My typical operation for a system is that I change the oil by changing the compressor oftentimes, because that's what you're usually in there doing if you have a burnout. And then what I will do is I will purge the system with nitrogen and sweep it in multiple different angles. So if I'm working on a big Lennox package unit, I'm going to take all the refrigerant out of the system, cut it in multiple spots. We're going to block the refrigerant lines off with our fingers, and we're going to blast it with nitrogen from one end, just kind of letting the pressure build up and letting it go. And you'll scrub the walls, and that works for me. Now, I'm not saying you can't use flush. I'm not saying nobody out there uses it. Lots of people use it, and it probably works fine. And I will say that I used flush for the first part of my career all day long, and as far as I know, I never had any problems with the flush. But it's just not something that George Robles, thanks for being a channel supporter for 21 months, man. That's really, really awesome. I really appreciate it, okay? And thank you for bumping up your monthly support fee. That's really awesome. All of you guys that support the channel, it's so humbling. Thank you very much. So I just personally don't like to use flushes because it's just an additive. I like to keep refrigerant oil in the system, and that's typically the only thing. I'll purge it with nitrogen, evacuate the nitrogen out, and just keep refrigerant oil and refrigerant. And that works for me. Again, not judging anybody that uses flush or leak sealers or dyes or anything like that. I just don't like using them. So, someone had sent me an email, and they said that they're just starting to work on exhaust systems, and he was trying to help a friend out, and he went onto the roof, and he was really confused on what this particular device. It was a giant metal box with an air hood on it, and it's called a makeup air unit, okay? So let's think about this with an exhaust system for a restaurant, okay? If you have an exhaust system, and the easiest way to understand this is take a paper bag. Imagine putting a paper bag and sealing it off against your mouth and inhaling. The air inside that paper bag, you are going to inhale the air that is inside that paper bag into your lungs, and the bag is slowly going to start to collapse because there's no more air left in it. So therefore, you're lowering the pressure and the bag is collapsing, right? But if you blow the air back out, the bag fills up and it'll become really full again. Think about a restaurant as a paper bag. If you put an exhaust fan on that restaurant and you just start sucking out the air, the doors of the restaurant are going to get really hard to open, because what you're going to do is you're going to create a negative air pressure in that building. And that negative air pressure, yeah, you might have a leaky building and you might have some air, but oftentimes the exhaust fan will overcome all the building leaks, and customers can't open the doors anymore, or they got to apply 30 pounds of force to open the door. And and then when they do open them, they slam shut when they walk in the door, because that building is under a negative air pressure balance. We remedy that by putting makeup air in the building. So the question that the gentleman asked me, he sent me pictures and he said, what is this device? That is a makeup air unit. It's there to make up for the air that the exhaust fan is pulling out. So let's go back to the paper bag analogy. You have that paper bag, you put it over your mouth, and you inhale, and the bag starts to collapse as you pull the air out of the bag, right? But if you cut a hole in the bottom of the bag, as you inhale, you are now going to pass air through the bag. You have put makeup air back into that bag. Now, in restaurants, we will have mechanical makeup air. Sometimes you'll have just barometric dampers, but majority of the time, you'll have mechanical makeup air that's forcing air back in. It's specifically designed to put the right amount of air back into that building compared to the amount of air you're exhausting out of the building. Okay, so hopefully that answers your question. And if it doesn't, send me another email. Okay, let me cross that one off the list. I'm kind of working my way through the questions. This is good. We're getting through them all. Oversizing a condenser fan motor. Someone asked about what can happen if you oversize a condenser fan motor, and or what about running the condenser in low ambient conditions, okay? And it really, that's a very loaded question, okay? Because if you say oversize a condenser fan motor, are we talking extreme? Are we talking that the motor and fan blade should be pulling 500 CFMs of air through it, and now it's pulling 5,000 CFMs, so now you're moving the air through that so extremely fast? I would ask the chat, I'm kind of curious, if you move air too fast through a condenser, I know what can happen in an evaporator, but if you move air too fast through a condenser, my initial thought is that theoretically you wouldn't be able to transfer the heat properly. But I'm curious if that's accurate. So I'd be kind of curious in the chat if anybody would answer that. I'm sure it would have to be an extreme amount of air, but if you're going from a very low amount of air moving through a condenser and all of a sudden you increase it tremendously, would that affect the heat transfer? In theory, it seems like it would. But to go even further with your question, something that I'm 100% certain on is about running a condenser and condenser fan motor in low ambient conditions. And the question is it bad to run a condenser in low ambient conditions? And it depends on how your system is designed, okay? If your system, oh, that's really nice, Ike, that you're gifting membership to people. Thanks, bud. That's really, really cool. That's really nice of you to do that, Ike. That's really cool. Thanks, bud. So if you're running a condenser fan motor in low ambience, if your expansion valve or your metering device was not designed to have a liquid temperature that low, then your metering device could have some issues in feeding properly, especially if it's a thermostatic expansion valve, because we have an operating envelope at which a compressor and a system can operate properly. And if it's outside of those operating envelopes, a lot of bad things start happening. So if you're running and you're cooling down the head pressure, that's the easiest way to understand it. If you bring your head pressure down too low, then theoretically your liquid saturation temperature is going to be affected, and the pressure drop that feeds that refrigerant through the expansion valve, especially if it's a thermostatically controlled expansion valve, may not be high enough to make the expansion valve operate properly. So if your head pressure goes down too low, your saturated liquid temperature goes down too low, then theoretically you don't have enough force pushing that refrigerant through the valve at the proper flow rate, so therefore the thermostatic expansion valve can't open and close properly, if that makes sense. So let's see if we got in here. I'm reading through the chat right now. Again, wow, guys, all the channel supporters, this is really awesome. Thank you very much. Everybody, Ike, you're the man, bud. Let's see. You're pretty sure we gave the bot a 3-year timeout. Or are we talking about like a night bot or something like that? Yeah, I haven't had those things turned on for a long time. All right, cool. That's it. I already talked about that. Okay, so I want to just kind of cover a few things. I've been getting a lot of emails, and this is more of an opinion thing, but I've been getting a lot of emails from people reaching out to me on a regular basis. Cyborg Chic, thank you very much for that super chat. Again, Ike, thanks for gifting those memberships to those people. That's really awesome, bud. So let me see what I'm missing in the chat here real quick. Have I had a job where the unit on the ground by the side of the building? Yeah, I have jobs where the unit's on the ground. I got a video that I had where I got a service call, late night walk-in freezer service call, and I went out there and tweakers had gone and stolen all the copper because it was down on the side of the building. So yeah, I've had lots of them. All right, I'm getting through the chat right now. Again, I haven't really been paying a lot of attention. If I have time, can I explain modulating exhaust fans? Yeah, I actually have a lot of history with modulating exhaust fans. In the past, there was a company out there called Maylink, and Maylink had a modulating, fully variable exhaust system. It was actually a really interesting exhaust system, too. The theory behind the mailing systems, I don't think that they exist anymore. I think they're still a test and balance company, but I don't think they make the IntelliHood anymore. But correct me if I'm wrong. So the theory of the IntelliHood by Maylink, which is a variable speed exhaust system, was that it had infrared like beams going across the hoods, and whenever it got really smoky, the infrared signal or whatever would be interrupted by the smoke, and it would trigger the system to go into full speed mode. So on the variable speed exhaust systems, a lot of the times, especially with the Maylink ones, the building was balanced at low speed, and it would only go into 100% speed or full speed whenever there was a high heat or a high smoke condition, or someone triggered the button because you could manually push it. Now there's several different manufacturers. I think Captive Air might even make a variable speed system too now. They might vary up by heat or different things like that. But they're really not too complicated once you start figuring it in there. They typically have a VFD, and the VFD, variable frequency drive, is programmed. They're 3-phase exhaust fans. And on the mailing system, it would be programmed to interpret signals. Whenever the laser beam or the infrared beam that went across there got interrupted by smoke, or whenever the temperature of the hood exceeded a certain threshold, the variable frequency drive knew that it was time to speed up the exhaust fans. So the smoke would get in there and boom, it would go to full speed. There was a lot of maintenance that had to be done on those systems. The little laser beam or photocell or infrared, whatever it was called, you'd have to clean the grease off of those all the time. And then they had pressurized air trying to push the grease off of them. I mean, they were pretty intricate systems. I had a lot of restaurants that had them, probably at least 15 to 20 restaurants. And I've probably bypassed quite a few of them because the restaurants don't want those variable capacity exhaust systems anymore. They were just a pain in the butt, and they were too expensive to fix. It was a great concept, but in the long run, they would go through VFDs all the time because they had no proper power conditioning to the building. It was just a mess. So I don't know if that explains it completely, but again, if I didn't answer your question enough, feel free to send me an email, hvacrvideos@gmail.com. So let's see. So you're not an HVAC tech, but when you walk into your walk-in freezer, is it normal to have frost in the air? Okay, so in a walk-in freezer, when you say frost in the air, is it actually blowing off the coil, or are you just seeing your breath, or is there frost on all the walls? You know, typically it's not normal to see frost on the walls. It's not normal to see frost on all the coils and stuff. It's not normal to see frost blowing out. That's typically an issue with the defrost or a fan delay switch. It's not completely normal, but it's also not unheard of, especially in like supermarkets and big box retailers. You're going to have iced up equipment all the time. So hopefully that answers your question. So when you walk in, it's foggy in there. Well, it's foggy in there because when you open the door, you're allowing heat to go in there, and that heat is affecting the air. That heat has moisture and different things in it, and it's causing like a foggy condition. So that's what's happening, is you have infiltration coming in. And then oftentimes if you have glasses on, your glasses are a high temperature, so they'll fog up because of the temperature change. Let's see what else we got going on in here. Okay, reading through the chat. No soup for you. Oh, I see. You guys were talking about a spam bot. I thought you were talking about the old night bot or whatever that I used to have in a long time ago. So I get it now. See, that's why I have all these guys in here being moderators. This is awesome. So let's see. Wow. Okay, cool. We're getting through there. You have to oil the zippers occasionally. I'm sure you're talking about the Vito Tech Packs and Pro Packs. A lot of people complain that the Vitos, they keep breaking the zippers. I'm going to tell you right now that majority of the time, not going to say 100% of the time, but majority of the time, if you're breaking the zipper on your Vito backpack or your Vito bag of whatever type, it typically means that you're overloading the bag or you're not opening it properly. You need to oil the zippers. You need to make sure you clean them on a regular basis. You don't want stuff getting in there. But if your bag is overloaded and you try to zip it up and it's hard to zip up, you're going to break the zipper inevitably. So I've broken several zippers on Vito bags until I realized how you're supposed to operate them. And now I've gone years without breaking a zipper because I'm very cautious not to overload the bags anymore. So let's see what else we got going on in here. Going through the chat. Tom Peltier. Sorry if I butchered your name, Peltier. He says R454B or R32. They're both different flavors of refrigerant. In my opinion, they're just another refrigerant, really. I don't have an opinion yet of either one. R32 is an A2L. It is a mildly flammable refrigerant. It's not a big deal. A lot of them are going to be A2Ls now. I think R54B might be an A2L too. I don't know for sure. R32, we already use R32, and a lot of people don't realize that it's one of the main ingredients in R410A. But because of the mixture rates, it doesn't get classified as an A2L because of the other refrigerants in there. But I don't have a preference of either yet. Yeah, it's hard to say. So I want to talk about, before I forget, I want to talk about HVAC software. So I get a million people asking me what software I use, what do I like about it, what don't I like about it. And then I also, especially since I get marketing emails all day long, I get emails from every software company out there, except for the two giant ones. I don't get emails from Service Titan. I don't get emails from House, or I don't know what the other ones are. I think at one point I got House Call Pro ones too, but they want me to promote their products, oh, show our product, show yourself using it. Why don't you switch to our product? I get cold calls from people about my business, all this different stuff. Guys, every software out there has hiccups and quirks, and they all suck, okay? It's just basically what works for you. Which one can you tolerate, and which one can you set up to work the best? Now, if you have the money and you design your own software, then it might work exactly the way that you want it. But every off-the-shelf software out there, you're going to have to deal with some things. So I currently use Intuit Field Service Management. I've used it for 10 plus years. It works for me, but I've been using it so long that I've learned how to work through a lot of the quirks and different things that can happen. The one thing that I will say about Intuit Field Service Management that I really, really like is they've had very, very few in the entire time that I've been using them down, like when the servers have gone down. It might have happened 2 times since I've been using them. They're really on top of that. They're owned by Intuit, so they're a big company. But there's things that suck about them. I don't use half the stuff in my software. I just use it. I create invoices out in the field. All my guys do it too. They'll call me and say, where do I go next? And I'll say, if I don't have time, I'll tell them to go ahead and create a work order within the app. They create a work order, they do en route, they put their time in it, and they go, okay? The one thing that I really do appreciate about software is consolidation of data. So we have service history for years and years and years of all the equipment we've worked on. So that's a big thing. So it's really about what you're comfortable with and what works for you. I'm not going to say there's any software that's absolutely perfect. I am getting Coke nose like crazy right now. All right. I'm looking through the chat, seeing what I'm missing here. But am I into it? Yes, I am into it, Laska. Have I ever worked on rack refrigeration, HVAC Bandito? No, I have not worked. Well, not regularly. I have worked on parallel systems in the past, but they were very small parallel systems and they weren't in like a supermarket. So, there's a big miscommunication here because When people say, do you work on refrigeration racks? Yeah, I work on refrigeration racks all the time, but I work on multiplex racks, right? Where you have one condensing unit that controls 6 systems, and sometimes they can have different components on there, but most of the time they're pretty dumb systems. Now, there's parallel rack refrigeration where you have 1, 2, 3, 4, 5 compressors that all share common suction lines and common header discharge lines, and they stage the compressors at different temperatures and different pressures and different needs. That's a parallel rack system. But then you have multiplex rack, which I work on multiplex racks all day long, okay? But oftentimes people have kind of gotten to the terms of thinking that rack refrigeration is just for supermarkets. I mean, a refrigeration rack is really a way to consolidate a refrigeration system and have it control multiple components, okay? Now, parallel racks, they can be very energy efficient if they're designed and maintained on a regular basis. But no, I don't work on parallel rack systems. I have seen them, I have touched them, but I don't work on them on a regular. I'm not comfortable giving advice. I wouldn't know my ass from my hand if I walked up to one. I mean, I could probably weasel my way through it. I could probably make a couple phone calls to a few really good friends and get my way through it, but I am not a competent person when it comes to parallel racks at all. So, you said that, I'm looking at Instagram comment. He says, you bought a house in the Inland Empire with no air conditioning. Should you go ductless, multi-zone, or a complete cut-in? Really, that's a preference issue. If you go ductless with mini splits, what you can expect is within 3 to 4 years, you're going to have very, very dirty systems, if not sooner. And if you need major components for your mini split system, more than likely they're not going to be available. Okay, mini split manufacturers are notorious for changing their designs and not having parts for a couple years later. I'm not saying everyone's like that, but there's a lot out there. So I'm more of a fan, and I'm about to do a home remodel system, and I'll talk about that. So I'm currently working on my own air conditioning system. I'm going to make a series of videos where I go through the process of changing my air conditioning system at my house. I've said this before. I don't know if everybody's heard this. We're going to make this a whole series, and we're going to go crazy with it, okay? I'm going to do my best to film this and make, and share how I learn about this, because I'm not a residential air conditioning technician. Now, this is not just installing a system, okay? Because if I just wanted to put a new air conditioning system on my house, I could do that no problem. That's a cakewalk, okay? But I'm going to design a system, right? So I'm currently working with my really good friend Adam Muffich, who's on the HVAC Overtime Show with me. If you guys don't know, the HVAC Overtime Show is a show we do on Friday evenings. It's a hangout between a bunch of friends. But my friend Adam is an HVAC. He does like high-end residential work in the Midwest. Anyways, so Adam's helping me start the load calculation on my house. So we're going to do a load calculation. Then what I'm going to do is I'm going to get my hands on a blower door. We're going to bring a blower door to my house. We're going to find out what my air infiltration is, how leaky my house is. Then we're going to get some high-end thermal imaging cameras, and we're going to go around the house and find the hot spots where I've got heat infiltrating through my insulation. And then I'm going to sit down and do some research and make some decisions. Is it worth it to spray foam my attic to eliminate insulation issues? Is it worth it to upgrade windows, right? I already have majority of the windows in my house are already new, but we're going to look at the envelope, the house as a whole. And we're going to do home improvements to reduce the infiltration of air coming into my house. Number one, because of heat, but number two, because we don't want nasty, dirty air. We're going to put a proper air filtration system on my system. We're going to redesign the ductwork. We're going to do it proper. I plan on doing rigid ductwork. Whether I do round or rectangular, I don't know yet, but we're going to do rigid ductwork with flexed drops off of it, short flex drops, but we're not going to do a whole flex duct system on it, okay? We're going to go through it, and by addressing the envelope and reducing the infiltration in my house, my hopes are that the system that I choose is going to be smaller than the 4-ton system that I have existing in my house. Now, ironically, I've been thinking about this a lot lately. So at the same time, let me finish that. I'm going to do this whole series. It's going to happen during the fall. We're going to be filming. I'm looking for people to work with me, manufacturers, different things like that. But I haven't fully decided what brand I'm going with yet. I haven't decided whether or not I'm going to put mini splits in my house. I haven't decided whether or not, everything's open in my head right now. My head's spinning, trying to decide what's going to be the best bet. I'm open to suggestions from all of you. I'm open to ideas. Feel free to send me an email, hvacrvideos@gmail.com. Okay. So in that, mini splits, that was something that crossed my mind, but I kind of quickly decided that I'm not going to put mini splits in my entire house because I know that it just leads to issues. Now, I may put mini splits in my office or something, or maybe not even I don't want to do a wall unit, but I might do a ducted mini split in my office because we have a really odd load in this room because of my giant computer that runs this and the lights and everything that I have in here. So it gets a little bit warm. So we might do like a single system for my office and then just a normal residential split system for the rest of the house. That's kind of what I'm thinking. But it really depends on what you're open to, okay? So mini splits, those will be cheap and fast. You can install them, but you're gonna be changing them pretty quick, okay? And cleaning mini splits, especially the wall hung units, it's kind of a nightmare. It really is a joke to clean those things. They have filters on them, but those filters, they honestly don't do much. The best filter on a wall hung mini split is the blower wheel, pretty much said. The blower wheel filters most of the air. It's kind of ridiculous, so yeah. All right, hopefully, I know I didn't really answer your question, but all right, let's see what else we got in here. All right. I'm looking at the chat. Renew Air ERV. Oh, I'm definitely bringing an ERV into the home too. So I want fresh air being a big part of my house, but we're not talking just a whole house fan with just a small little duct. I want serious fresh air. So I'm contemplating, again, I'm not saying I'm going to do this. I'm going to investigate spray foaming my attic, completely sealing off my attic, using my existing gable vents as fresh air for the house, and ducting fresh air into the house through an ERV and, doing that. So there's all kinds of ideas that are going through my head. I'm open to all kinds of suggestions. It's going to be a fun project. I want to have fun with it. We're going to film it. We're going to make it fun. Again, I'm trying to find manufacturers that are interested in working with me. So we'll see. We'll see how this goes. Scott, thanks so much for that super chat. I really appreciate you, bud. What the heck is it with, when you have live streams that are doing well, they get attacked by these stupid bots, and my moderators are doing a great job getting these bots out of here. Thank you guys very much, but it looks like we're being attacked by a spam bot right now. Those things are a pain in the butt. Control Alt and delete them. That is absolutely right. All right, well, it is time for me to go. I really, really appreciate y'all making it to the live stream. Instagram, let's see. If you guys like it, I'll continue to do the thing on Instagram. Hopefully next time we'll be able to do the Facebook thing too. I don't know what happened with it, but streaming stuff is not my forte, even though I do it all the time. It's kind of weird, but I really appreciate y'all. I'm going to cue up the outro music, and we will catch you on the next one. One thing real quick. What do I think of VRVs? Also, have I worked on them? I really haven't done a lot of work on VRVs, variable refrigerant volume. So, it's just a system that varies the refrigerant flow via inverters and different things like that. I haven't worked on a lot of them, so I don't have a lot of experience with it. So I'm going to go ahead and end the live on Instagram. So see you later, Instagram. And let me click end on that. Okay, so we did that. And I am going to go ahead and cue up the outro music. I really appreciate it. Thanks so much to all the moderators. I know you guys were working hard tonight. I really do appreciate you all. And yeah. That's it. So as usual, I'm going to cue up the exit music and the outro stuff, and we will catch you on the next one. Yo. Come here, buddy. You want to come say hi? Come here. Come here. Come on. Come on. Come on. Oh, there's my buddy. Oh, yeah. Yeah. You know that he just licked his junk, and now he's licking my face. What's up? You want to say hi? Raw. Raw. What's up, buddy? Say hi to everybody. Say hi. Yeah. Okay. It says, all right, peace out, guys. Yeah, that's about